Back, Chapter 2, Section 2.3, Differentiation Formulas. So far we have been looking at the finding derivatives using the limit definition. Now, we want to come up with formulas. Alright, let's start with the simplest of all functions, the constant function fx equals c, that is slope equals 0. You can see from here itself that the derivative has to be 0 because your line is horizontal. Function fx equals c gives me y equals c, which is a horizontal line. Sorry. Graph of this function is the horizontal line y equals c, which has slope 0. So we must get f prime x equals 0. Here is the definition proof. F prime x is limit h approaching 0, f of x plus h minus fx the whole over h. F is constant function, so no matter what your input, output is c. No matter what your input, output is c. So c minus c over h. This is 0 over h, which is a 0. So limit is 0. In other words, derivative is 0. Using the definition and also using geometry. Alright. So derivative of a constant function is 0. This is your very first formula. Now let's go to power functions. Fx equals x to the n. When n equals 1, the graph is f of fx equals x is the line y equals x. Notice this has slope 1 because rise of 1, run of 1, rise of 1, run of 1, and so on. So this has slope 1. So we are expecting the derivative of y equals x to be 1. So here you can verify this using the definition of a derivative. We have already seen cases n equals 2, n equals 3, that is x squared. You can check using definition. D by dx of x squared is 2x. D by dx or derivative of x cubed is 3x squared. Alright. For n equals 4, look at the derivative. X plus h power 4. The expansion is precisely here x to the 4, 4x cubed h, 6x squared h squared, and so on. So x to the 4 cancels x to the 4. You are left with only h terms. Get an h out and you divide by that h and you are left with one h less in the numerator for each term. Now when you let h approach 0, all these go to 0. You are left with 4x cubed. Okay, which brings me to the derivative of x to the 4th to be 4x cubed. In general, derivative of x to the n, that is power n comes down and power reduces by 1. That's the power rule. If n is a positive integer, then derivative of x to the n is n x to the n minus 1. Fx equals x to the 6th, derivative is 6x to the 5th. Y equals x to the 1000, derivative is 1000 x to the 999. Y equals t to the 4, then derivative of y, 4t to the third power. Derivative with respect to r of r to the third is 3r squared. Alright. So notice variable matters. You are taking derivative with respect to the independent variable. Alright. New derivatives from old derivatives. Now, constant multiple rule. So what happens? So far we saw derivative of constant function and derivative of the power. What if you have a function and you are multiplying it by a constant? So new functions are formed from old functions. Addition, subtraction, multiplication by constant, and then you want to find their derivatives of the new functions formed from old functions. Alright. When new functions are formed from old functions by addition, subtraction, or multiplication by a constant, their derivatives can be calculated in terms of derivatives of the old functions. In particular, the following formula says derivative of a constant times a function is constant times the derivative of it. Do you understand what that means? If I'm taking derivative of some number times a function, you can safely bring the number out and take the derivative of the function alone. Okay? In other words, derivative of 3x to the 4, I can bring 3 outside and then take derivative of x to the 4th. We just saw derivative of x to the 4th. 4 comes out, x to the 3rd. So in all, it is 12 x to the power 3. Likewise, derivative of negative x. Negative means what? It is negative 1 times x. So I can safely bring out that constant out and take derivative of x. We know derivative of x to be 1. So answer is negative 1. Alright, I will continue the next rules in our next video. Until then.